Hello, it's Ibrahim again. In this video, we're going to talk about histograms, and as you all know, it's used in many fields, and it's heavily used in photography, mathematics, and so on and so forth. And photography, it's very important because it's a very handy tool to actually know if your image has been properly exposed, to see it and to assess the what do you say the in terms of the brightness, if it's does it have proper lighting and so on and so forth. So it depends on the type of scenery that you're shooting or the type of image that you want to take. um, the histogram would serve a purpose in that terms. Let me explain further. Say, for example, I've just Googled histogram in photography, and you'll get to see many articles that talk about it, many useful articles as well. As you can see, there are different types of graphs that you want to look out for. Say, for example, in this case, let's say this image here, you can see that there is a lots of darker shades here, shadows and stuff. So you would want your histogram to look something like this, And in this case, it's more focused on the highlight itself. So it's more towards the right hand side. And similarly, many other objects, if you're shooting a normal scenery without even focusing on the shadows or the highlights and so on and so forth, so you would want it to be centered, something like this. So I think this explains it very well. Now this is basically overexposed, too bright, and this one underexposed, too dark. This would be suitable for darker images, shadows and stuff, and this is for brighter images, and this for something with, you can say, something like balanced thing. Let me try to look for images or examples. Yeah, this is a good example here. As you can see, this is overexposed, and this is um, sorry, yeah, this is basically an overexposed image, and this is underexposed image. And as you can see, you would want to achieve something like this or if you're shooting, it's more like towards the center rather than towards the right hand side or to the left hand side. So yeah, I think that's as simple as it gets. It's a very handy tool, to be honest. And the good thing about OpenCV, and you can actually do something like this. You can actually create a tool that generates histogram for your images. So let's see how that's done. So let's start up with, as usual, we need to import CV2, and we also need to import numpy as np. I'll explain why we need numpy here. So as always, we need the image. We read the image using cv2.imread, .imread, and then we supply in the path to the image and the type of whether be it a grayscale image or its color. So we can just leave it as is, and then we just read. I'm going to use banana, our favorite image. So let me just verify that the image, that the banana is actually there. So yeah, it's actually here. It is the banana image. So we want to generate a histogram for this image here. So now, as always, img now is the object that contains the format OpenCV understands. It's a kind of it's presented in an array, and we can get the shape of the array. Let's print the shape of the array just so, because it's very important to understand more concepts down the line. Now that we've loaded the image, now what we need to do is we need to generate. Now you could actually, of course, you could check if the image is none just to verify the image has been loaded properly and stuff. Now we're going to skip those validations just to speed things up. Now let's generate the histogram. Now histogram, let's create a variable called histogram, and there is actually a method that we could use which is called calc_hist, like so, and takes in a couple of parameters. Just give me 1 second. Let me load this. Let me load the parameters it takes. Let's load any documentation here. Better be okay. Let's just load this one here. Now calculate histogram takes in images, channels, mask, hist size, range, and these are optional. Now let me explain what these are. Okay, so basically it takes in the image, and I believe, as far as my knowledge is extended, I believe this has to be in square brackets. And there is also the channels here. The channels is basically either you want it to be it's a sort of an index, either be it a grayscale or red or blue channels. If you want to focus only on the red, green, blue channels, you'd want to use the index 0, 1, 2, and so on and so forth. Now, we will just stick with the default, or just go with 0 in this case, and you can try it out later. And it takes also a mask. If you want to generate a histogram for a specific region in an image, then you would want to use this mask. You can generate a mask that you desire. And hist size is basically, say for example, you have an histogram. Let me just try to look at an histogram here. Now this, if you take a look at this, these are 0. Now these are the pixel numbers, and this is the value of each pixel. Say the brightness of the brightness value of each pixel, and this is the number of pixels that exist. Say for example, let's assume that you have pixel number 1. You're going from top to bottom, and then you have this pixel here. Say for example, this pixel has a brightness value of 0. Now you can see here as almost there is none. So assuming what this means is that there is no pixel with the brightness value of 0. So basically this stolen range means this is where most of the brightness pixels exist in. So most of the brightness pixels exist on this range, this stolen range here. You can see that mostly between, you can say, I'm not sure what the number is here, but this 0 from 2 to 55, which means there are 265 values for the brightness. So from 0 to 255, and this is the number of existence of each of the values here. Now I think that's very simple. So what you could also do in histograms, you could actually divide this to multiple regions. Say from 0 to number, 0 to 64, 65 to something, to 1 to something, and then so on and so forth. So if you decided to choose 4 regions, each region would have a number combination from 0 to 64, so 64 values on each region. If you decided to divide it by 16, you will have 16 values on each region. So instead of each pixel having one value, if you decided to divide this by 4, now which means 64 values. Now say for example, you have a number of pixels that exist between the range 0 to 64. They will be calculated all together cumulatively in this region. So you will have 4 values, 0, 64, and so on and so forth, and the graph would vary drastically. And we will look at an example, in a bit. Now the ranges here are basically, if you decided to choose, then there is also something else here called the range. The range of values, again, is basically from 0 to 255. If you decided to choose a certain number of values that you want to calculate for, so if you decided to choose maybe from 0 to 2, so only those pixels with the values of from 0 to 2 to, say for example, to the number 2 will be calculated. Otherwise the others would be ignored. So yeah, I hope that makes sense. So again, so what we have here now, this is basically the function that does the processing for us, that generates the histogram for us. Now it does not generate, let me just be clear on this one, it does not actually generate the image for us. It simply generates an array that represents the histogram, and then we could afterwards, we will see how to do that in a bit, and how to draw the array to convert it to a plot. We'll do that in the later on as we see as we start to code. As we finish coding, sorry. So anyways, now this function here takes in the image that we want to calculate the histogram for, and this is the channels. Basically you have the red, green, blue, so these are basically represented by an index. If you decided to choose the gray, you can go ahead from 0, 1, 2 to represent the red, green, blue. So I will, yeah, and then the mask, if you want to generate a histogram for a specific region in an image. The ranges, if you decided to use the whole ranges, the brightness ranges, or something from 0 to 255. Say for example, you're only interested in the values 160, from 160 to 162. In that case, you would want to specify the range 160 to 162. So any pixel with the value lower than 160 and larger than 162 will be ignored and won't be calculated in the histogram that you want to create. Now, yeah, these are the most important ones. So I think that it will be much more clearer if we actually start to code something and start to implement it here. So yeah, let me go on with this now. Let me try to copy and paste the parameters here, just so we won't forget what we're dealing with. There we are. Let me just copy and paste this, comment it out, and there we are. So the first thing we need is the image. As far as my knowledge is extended, it has to be in square brackets, but let me go ahead and just put it as is. Channels, we just want to work with 0 now, for now. We're just with the grayscale image. Now if you want to work with other channels, you can use the indexes 1 and so on and so forth, 1, 2 and so on. Now the mask, we do not want to use any mask, so we'll supply none here. And the hist size, what we want to do is we do not want to divide the histogram to blocks. We just want to use the whole thing, the whole range. So what we want to do is we want to use 256 values here of each pixel would have its own value. And then the ranges, we want to use the ranges from 0 to 260 to 56. There we are, 255, sorry, 255. So these are the brightness ranges from 0 to 255. Now that we have an histogram, how about I just want you to see the type of this histogram. Why do we need the type here? Sorry, the shape. The reason why we need the shape here is so that we could, now that we have the array, we want to create a new image that complies with the shape of this histogram, so that we could draw the histogram over the image. Now in this case we can, you know what, let me not complicate things here. How about we just print the histogram, the shape, and then we also print, let me just print this, and then we shall print the histogram itself, just so we see the type of object that we have in here. So let me save and run this module. Oh, oops, we have a typo here, and this should be the output. So let me run the module, save. So now we seem to have a problem. So yeah, we forgot to add CV2 here. What else? We seem to have a problem without an exception set. Okay, so we seem to have a problem in here. Now the function is not properly structured. Now this has to be supplied in square brackets like this, and this one also needs square brackets like this. This is in the documentation. Just check out the latest documentation. Now all of these, sorry, I forgot to also add this in the brackets. Now this is actually mentioned in the documentation that you actually they need to be supplied in square brackets like this, and just because I consulted the older documentation, it does not mention that the brackets are actually required. So yeah, so that's basically was the problem. And again, let me just show you something here. As you can see here, this is the shape of the original image that we've loaded, and this is the shape of the histogram that we created here. Now you can see here that there are points now. Now this is the histogram that we've generated. However, to draw this, well, this format, well, it's not actually something that we can actually present. We need to have something like a graph or a plot, and fortunately in OpenCV this is very much achievable. Now we need to convert this to x and y coordinates. To do that, it's very simple. So let me show you how to do that. Now we need to convert the histogram, this array here, to something with x and y coordinates. To do that, okay, in order to do that, we're going to use enumerate. There we are. So, and then we supply in the histogram, and this will actually generate x and y points. Let me just print this, just so you know, and just to separate this from the rest, let me just copy and paste this. There we are. Now this basically would be put as an x and y representation. Now we need to draw those representation into a plot or a graph. What we need to do, for each of these points we need to draw the line. And in OpenCV or CV2, the line to be drawn basically takes in the x and y points, and then the color of the line and the image as well, just like we have seen in the rectangle and other drawings that we have presented earlier in the previous videos. Now let's loop through the array. So for, and then x generates x and y points like so, in enumerate, and then histogram. I've printed this one here just to show you how it would look like, yeah? And then we need to supply in the image that we need to draw the line using cv2.line, and it takes in the image that we want to draw on. Say for example, if we decided to draw on the original image, but the problem with the original image is that, you know what, let me just draw the histogram on the original image, and then I'll show you how we can fix the problem. And then it takes in the x points from x to 0, starting point, and then x and y, and then it takes in the color, and I will just draw 255, 255, 255. You can choose any color you desire, and then just so now this will print the object. Now how about we print the x and y coordinates like so, print x and y, just so you see how enumerate can actually convert the array to x and y values. And there we are. So what we also need to do, let me go back here, and then we need to, okay, so we draw on the line. Yeah, we need to display the image using IAMShow like so, and then we supply in, let's say, a title, histogram, and then the image that we want to display. Since we're displaying an image, we want to display image, and then we wait for any key to be pressed. There we go. So let's give this a run and see if it actually works. Now we have a syntax problem here. We forgot the colon. There we are. So this is basically the drawing, and this is the drawing that has been generated. So these are the x and y values. Now you can see 233 for point 233, which is something around here. Draw on the line of y somewhere around here or here. I'm not really sure. Since we have thousands here, so it should be probably around something around here. Now you can see the histogram is not really clear because it's been drawn, it's white color, 255 to 55. You know what, let's just do this and it will make much more sense. Let me just run this, and you can see that this is the histogram. It's not very clear, simply because we're using a background that's not very, it's not very beautiful. So this is there's a white background in here, so we have to work with the colors a bit. Or we have another option, is that we could create our own image, say a white image. Let me just put these 255 as they were. Let me generate my own image using NumPy. We can create our own image that we know. Now note here, there's something we need to consider here though. Let me just close this image here, and let me close this image as well. And you can see here that we've printed the shape. As you can see, this is the enumerate here, this is the object, and then I just want you to see the shape here. Now you know that the shape is 256. Now this is the shape of the histogram. Remember, this shape is the original image, and this shape is of the histogram that we have. Now we need to create an image of the same shape so that we can draw the histogram or the image, so there will be a compliance with the array type and range and so on and so forth. So 256 and 1. So let me go ahead and create my own image here. We can do this here using NumPy. Let's say blank would equal MP. Now this is why NumPy is actually important. That's why we imported NumPy earlier. Now we zeros take us in the shape that we want to create the image. It takes in the shape and the type. So in this case, we know that the shape is 255. It's 256 and 1. 256 and 1. So we can go ahead and create the shape as is. Takes in a tuple 256 and 1. We can do that, and we supply in the type, be it integer 8 or NumPy array if you please, but we can just leave it to blank. and then instead of us supplying blank image, the original image, we can supply blank here, and then we can display blank like so. Let's give this a run. I think I should have commented this. As you can see, now this is the shape of the histogram. It's basically it's very tiny here. Now what we need to do, if we decided to increase this to the full range, now this is the range 256 values and the range of 1. Now we need to supply 256. Now this is basically 255. You know, we can keep it as is, 256 and 256. Let's see if this results something useful. And here we are. I think this is very pretty. Now basically this is the histogram for the image that we have supplied. We can try different images as well. Let me try to play with the numbers here just to verify if this actually has something to do with it. I should have commented it out. So basically it's the same. There is not much difference here. You can see it's identical. So yeah, that's basically, so the blank at the background here is basically this image that we've created just now, and then we've drawn the histogram over it using the enumerate to convert the histogram to x and y coordinates, and then we just created the image as is. Now how about we decided to choose another image? Now we have a couple of images that we've used earlier. How about we use pond? Now just by guessing, this pond here would have some dark sides here, and then so let's see how the histogram would look like for this one. Now we have pond. I believe it's JPEG. Or it's ping pond. Yeah. So it's pond. I'm not sure why I was thinking about pings. Okay, there we go. I should have commented this out. Anyways, so this is the histogram for the image. Actually, the image that I've used is actually photoshopped, and it's been played around with the colors and stuff. So let me try to use a different image. Maybe this is a laptop. I don't have proper images here, which is quite embarrassing. So let's choose laptop 2. Okay, there we are. Let me comment this out just so we avoid the long queue. There we are. So this is the histogram for the image that we have just seen. And of course you could play even further. Now banana I think has a better histogram, clearer one, banana. So basically that's it. I hope that was helpful. And yeah, also you could play around even further with the numbers here. So for example, with the hist size here, you could divide this to portions. However, you should also note that you would want to change the image that you're drawing on as well, just to comply with the ranges that you are actually displaying. So yeah, I hope that was helpful. Thank you for watching and have a good day.